The European Space Agency has been sending astronauts deep underground as training for extended stays on the International Space Station. In the early 60s, during the Mercury program, the United States began developing a giant booster capable of carrying a crew of 3 to the Moon. It used a cluster of tanks originally designed for other rockets, and the first flights just tested a mammoth lower stage. It became known as the Saturn I. Launches began in 1961, but although it could lift heavy loads, without upper stages it could not reach orbit. Engineers were expecting the usual teething problems with the big new rocket, but there were none. Every launch went as planned. At the same time, the new, much larger Apollo spacecraft was being developed. The initial Block 1 version was designed when NASA still envisioned the capsule with a large descent and return module would land directly on the Moon. Several of these early models were built as test articles before NASA settled on a modified Block 2 design that included a docking probe and would work in conjunction with a lunar landing craft. Like previous American spacecraft, the Apollo capsule was designed to land in the ocean. Every situation was rigorously tested, and sometimes the value of these tests was glaringly obvious. The Apollo capsule was fitted with an escape tower, like its Mercury predecessor. In an emergency, sensors would trigger the solid fuel rockets, which would pull the craft away from an exploding booster. This was tested from a specially designed Little Joe rocket. During tests in 1965, the Little Joe was meant to test a high altitude abort, but just 26 seconds into the flight, the rocket developed a roll. It was a genuine emergency, and the system had worked perfectly. All across the US, different Apollo subsystems were being tested simultaneously. Though NASA now felt it had achieved parity with Russian technical ability, it was still in a race to the Moon, still focused on President Kennedy's end of the decade deadline. It was a masterly feat of organisation. NASA enjoyed generous funding and popular support, with the United States going through a space-led technical revolution, and astronauts rivaling movie stars as figures of public adulation. By February 1966, a Saturn IB was ready for an unmanned all-up test. This was a new technique for NASA. All-up testing meant testing a range of new systems in the one flight.
6, 5,
If all went well, it would save a lot of time.
engine sequence start. 1, 0, launch commit. We have a liftoff. All engines building up thrust. Moving out.
The Saturn I lower stage had been improved and was now known as the S1B. This time there was a second stage, the S4B. The combination would lift a Block 1 version of the Apollo spacecraft for its first flight. The capsule splashed down in the Atlantic 37 minutes after launch. The mission was generally a success, though there were engine difficulties, and wiring problems led to a loss of steering control and distortions in telemetry data. The focus now shifted to the first manned flight. Gus Grissom, one of the original Mercury 7 astronauts, Ed White, the first American to walk in space, and first-timer Roger Chaffee would crew an old-style Block 1 Apollo capsule in a mission scheduled for February 1967. Grissom had done valuable work in the development of the Gemini spacecraft, and he'd commanded the first Gemini mission. He'd taken on a similar role with the new Apollo command module, but he was becoming frustrated. He was concerned about the lag between changes made to the command module and the corresponding alterations to the simulators. The amount of flammable material that was in the crew compartment was also raised several times. While the booster technology was progressing steadily, the sheer complexity of the spacecraft was seeing it slip behind schedule. NASA was finding numerous deficiencies with the quality delivered by contractor North American Aviation. Another aspect of the astronauts' work involved an ever-expanding commitment to the mass media. Since its inception, NASA had decided that its activities would all be open to public scrutiny, in contrast to America's Cold War adversary, the Soviet Union, which chose to shroud its space program in secrecy. NASA's Public Affairs Office employed journalists who understood what working journalists needed, yet it was clear that the astronauts found photo calls a distraction. Regular press days were held in the lead-up to the mission. As the launch day approached, training in simulators shifted to testing of the spacecraft itself, sometimes in a vacuum chamber and sometimes as it sat atop its booster. One of these procedures, known as a plugs out test, was to evaluate the Apollo capsule's function while it was disconnected from launch control, operating independently on its own power. There was no fuel in the spacecraft or in the booster, and all the pyros and explosive bolts were disabled, so this was regarded as a very safe situation. All other parameters would be the same as in a live countdown and launch. The astronauts would breathe pure oxygen at slightly above atmospheric pressure. This early version of the capsule had an old-style hatch that opened inwards. It would be held in place by the internal pressure. Later manned missions would have a different outward opening hatch. For hours, the simulated countdown stopped and restarted, but at 6:30, a spark triggered a flash fire. In the pure oxygen environment, it consumed the capsule, killing the 3 astronauts in seconds. The United States was in mourning. Gus Grissom, Ed White and Roger Chaffee were buried with full military honours. Many at NASA had been dreading this kind of outcome. In a speech to colleagues at Mission Control, Flight Director Gene Kranz said, "We were too gung-ho about the schedule, and we locked out all of the problems we saw each day in our work." Manned flights were suspended. The space agency had to find out what went wrong and then completely redesign the capsule and mission procedures. All Apollo remnants were impounded, and NASA initiated an exhaustive investigation. Both houses of Congress also set up inquiries. Frank Borman was the only astronaut to serve on NASA's Accident Review Board. He was one of the few astronauts to serve as commander on his first mission, Gemini 7, and he'd been selected to command the 3rd manned Apollo mission, but there was a cloud over the whole program. Ultimately, Borman's testimony before a House committee helped convince Congress that the manned Apollo program was safe to resume operations. Outside the inquiries, NASA tried to maintain its focus. Astronauts who were experts in every aspect of flight and related engineering were now being sent on field trips to learn about geology in preparation for moon missions. Although manned missions for 1967 had been put on hold, NASA still scheduled flights. The giant Saturn V booster, needed to get to the moon, was finally ready for launch. There had been delays with the second stage. Apollo 4 would be another all-up test, which included the problematic command module. On delivery from contractor North American Aviation, it was subjected to close scrutiny. More than 1,400 problems were discovered. The response of NASA managers, who were close to the Apollo 1 astronauts, ranged from fury to tears. Remedial work on the command module took 4 months, with Apollo 4 finally ready for launch in November 1967. The new rocket was covered in sensors, and cameras would record critical
Ignition
functions.
Sequence starts. 5, 4, we have ignition. All engines are running. We have liftoff. We have liftoff at 7 a.m. Eastern Standard Time.
My God, our building's shaking here. Our building's shaking. Oh, it's terrific. The building's shaking. This big glass window is shaking. We're holding it with our hands. Look at that rocket go into the clouds at 3,000 feet.
The cameras, intended to monitor the intricacies of staging, captured some of the most iconic images of the Apollo program. They were jettisoned soon after these pictures were captured and parachuted back for an ocean recovery. At this point, nobody knew whether President Kennedy's goal of a lunar landing by the end of the decade was achievable, and the Apollo 1 tragedy was making a lot of Americans have second thoughts about the race to the moon. Working on the International Space Station involves very specific scientific tasks, in combination with having to deal with the unexpected. And although ground control will provide advice, astronauts must be resourceful and good at solving problems. Space is a hostile environment, and their lives could depend on it. As part of its astronauts' training, ESA runs a regular caves exercise, where astronauts from across the ISS's partner agencies come to work together in Sardinia's Sagruta cave system. ESA has been running caves for 8 years. It's a convoluted acronym of Cooperative Adventure for Valuing and Exercising Human Behaviour and Performance Skills. The lack of a day-night cycle, sensory deprivation, claustrophobic spaces and an absolute need for good teamwork provide a strong analogue with spaceflight. Each new group meets for a training program that is also a multicultural team-building exercise. Experienced cavers brief the astronauts on what they can expect. This team will spend 6 days in the caves, though previous expeditions have been underground for as long as 2 weeks. The caves training is not just an endurance test. The team is expected to do some serious research. Last year's group discovered a new species of crustacean within the caves. The participants also learn 3D mapping skills and are expected to survey 1.5 kilometres of the largely unmapped Sagruta system. Before their long underground expedition, the astronauts visit several small caves to familiarise themselves with the routines. In orbit, they are the arms and legs of the extended science team on the ground, and a similar plan is followed here. The group will be measuring carbon dioxide and radon levels, as well as taking microbiological samples. These detailed scientific measurements are carried out according to strict guidelines. On the first day of the expedition, the astronauts say goodbye to the usual pattern of day and night. For the next 6 days, the only light they will have will be from their headlamps. Though they will still follow a daily routine, there are no visual clues to the passing of time. Each team member carries 2 short tethers at his waist. Safety protocols, similar to spacewalking, require these to be used in all dangerous situations. Discovered in 1950, the Sagruta cave system includes both dry and wet caves. Humidity levels throughout the system are uniformly high, and year-round the temperature remains at 14 degrees. The team spend several hours making their way to a central gallery where they set up a base camp that will serve as their centre of operations. Tents are necessary because of the constant dripping. The ready availability of water makes this a good campsite. Here, the technical instructors delegate all planning and decision-making authority to the team's elected leader. The daily routine is organised around timelines. Just like teams on the International Space Station, every day's activity is planned in advance. The group explored 2 branches of the cave system, going past an area named Lake Baikal and continuing on into galleries that had not been seen before. They were looking for a forward campsite, but could find nowhere suitable. The next day, the team donned their wetsuits. They would explore a riverine area mapped by the previous expedition. Since a test course in 2008, more and more situations similar to spaceflight have been introduced underground. Though the physical demands placed on the astronauts are not extreme, they are under stress. The lack of light makes movement and equipment handling more difficult, and the absence of a day-night cycle distorts the perception of time. ESA believes the cave environment provides an exceptional training for long-duration spaceflight. At a cavern called the Ballroom, the group have reached the limits of the map. They press on into an uncharted region where they discover 2 huge new galleries. Just as in space, making an accurate photographic record is an important part of the documentation. They decide they'd like to establish a forward camp here, but before they can, mission protocols say they must inform cave control. Making radio contact through more than 100 metres of solid rock is impossible, but they have a type of digital telephone that transmits using the conductivity of the wet ground. The group spend 2 more days in the area recording the insect population, taking water and air samples, and mapping the galleries. Finally, it was back to the surface, where hot showers and cooked meals were waiting. But before they return home, the final phase of the operation has to be completed. All the research work must be written up and presented.
Allumage Vulcain. Allumage des EAP.
May the 14th, 2009, and an Ariane 5 launches the Herschel Infrared Telescope and the Planck Space Observatory. Planck was headed to a Lagrangian orbit around a point 1.5 million kilometres beyond the Earth.
Tous les paramètres à bord sont normaux.
Its job was to map variations in the cosmic microwave background, or CMB, the remaining echoes of the Big Bang at the beginning of the universe. To do this, it had to be sensitive to differences in temperature across the sky, down to millionths of a degree. While it was operational, its detectors had to be refrigerated to 1/10 of a degree above absolute zero, making it the coldest object in space. As it scanned the skies, it slewed with a high degree of precision, enabling it to make a three-dimensional map of the universe across 9 different wavelengths. When the CMB was first observed in 1965, it was seen as uniform in every direction. Instruments that could detect its minute variations did not exist. Images formed from different wavelengths give clues to the formation of the galaxies, and data from Planck has changed cosmologists' ideas about early star formation. Evidence now suggests the first stars ignited 140 million years later than had previously been thought. As the early universe cooled, light flooded the skies. As the universe continued to expand, this light faded, yet the CMB persists, providing an image of the universe in its infancy. Not only is the accuracy of information from Planck allowing cosmologists to recalibrate the timeline of the universe, it's prompting revision of the theory of inflation that doesn't fit the picture revealed by the probe. Planck was decommissioned in October 2013, when the depletion of its helium coolant rendered it inoperable.